So in our last video, we argued that our optimal choice of output, given a cost function and given a price, is going to be the point where price equals marginal cost, and where marginal costs are increasing, right, a point like this. And the reason we said so, right, the reason we made this argument, is because we said if we produce anything more than this, we would end up making a loss on that last unit that we produced, right? We'd be losing money by increasing our output, because our marginal cost would be greater than our price, right? The cost of producing that unit would be more than the revenue it brought in. If we produced less than that unit of output, we'd be leaving money on the table, right? We'd be failing to produce some output that would bring in more money than it cost us. But in this video, we're going to talk about a little bit of a wrinkle here. So if we have a situation like the one depicted in this graph, where our marginal costs start out high and then decrease, but then at some point increase again, it's a little bit unclear, just by looking at marginal cost and price, whether it's worth it to produce output at all. What I mean by that is, in this area here, right, each unit is bringing in more money than it costs us, so we're earning a profit. Right, this whole area here is profit. But the first couple units we produced, before marginal cost fell below price for the first time, we produced at a loss. Right, all these units here. And so if all we know is that our marginal cost is eventually greater than the price, eventually crosses price from below, we can't know whether the profit we made on these profitable units was greater or smaller than the loss we made on these unprofitable first couple units. In other words, there's really two potential best choices for us of how much output to produce. We might want to produce here at Q star, right? But we might also want to produce here at 0. We might not want to waste our time with all this mess. So how do we figure out which of these is the right answer, right? Whether we're better off at Q star or at 0? There's really two ways we could do it. One is we could add up our losses and add up our profits and see which one's bigger, which would implicitly mean in this case, right, taking an integral to find the area of this shape and the area of that shape. But we have an easier way to do this that doesn't require us to do integrals. And what that is we can figure out essentially what the difference in costs are between 0 and Q. So what we can do is we can define something we'll call variable cost. Which is the difference in cost of producing Q units of output instead of 0 units of output. In other words, it's going to be the cost of Q units minus the cost of 0 units. It's going to be variable cost of Q. Why do I want to subtract the cost of producing 0 units? Well, let's remember in our example, right, that $80 we spent on capital. If we decide not to produce anything, we're still paying those $80. So they shouldn't factor into our decision, right? They're not going to determine whether 0 is better or worse than Q star. So essentially what we can do is we can say, well, if our variable costs are greater than our revenues, right, since our revenue at 0 is 0, then it's worth it to produce. Or it's not worth it to produce, right? Produce if revenue, P times Q, is greater than or equal to our variable costs. Right? The difference in revenue between producing Q and producing 0 versus the difference in cost. Now, in order to have everything kind of on the same scale, be able to put everything on the same graph, we like to divide this equation by Q. So we'll say P has to be greater than or equal to our variable cost of Q over Q, which we'll say is the same as P, right, just to remind you, greater than or equal to C of Q minus C of 0 over Q. I'll call this thing my average variable costs. Average, right, because I'm just dividing the total by Q. Average variable cost of Q. Awesome. So what will average variable cost look like on a graph like this? we can think about this using the exact same tools we worked out when we were thinking about marginal product of labor versus average product of labor. Right, so the average and the marginal cost of the very first micron of output, exactly the same. But then, because our costs are falling, our marginal cost is falling, each unit is the cheapest unit ever produced. So each unit is going to be cheaper than average, right? And our average variable costs are going to decrease, though at a slower rate than our marginal costs. Even as our marginal costs start to increase, we'll still have average variable costs falling, as long as marginal cost is below average variable cost. Average variable cost will then hit a minimum, right where it hits marginal cost, at which point it'll start to increase. So the way we drew this here, right, where we have average variable cost falling below price, what we do is we'd essentially say our benefits from producing Q, instead of producing 0, are going to be the average variable cost of Q. You know, I'm actually going to redraw this to make this a little bit more obvious, if you don't mind. Right? So this is the average variable cost at Q star. We'll say that this difference between price and average variable cost is the average profit we'll make on each unit, right? Our profits per unit, our benefits per unit, our profit per unit. And this rectangle here is going to be our benefit from producing Q star instead of 0. Does this make sense? Essentially what we're saying, right, our benefit of producing Q star instead of 0 is the difference between the revenue we get for each unit and the average cost of each unit, ignoring the cost that we would have incurred if we didn't have to produce anything at all. We'll call this rectangle here, this benefit from producing Q star, our producer surplus. Which is just going to be price minus average variable cost times Q. Right? Exactly what we're seeing in this rectangle here. The benefit we get per unit times the number of units that we produce. So in this case here, right, as we've drawn it here, because we have a price greater than our average variable cost, we're going to have a positive producer surplus. It's going to be worth it for us to produce Q units of output. But if our price was lower, let's say our price was here, we wouldn't come to that conclusion. In this case, we would say, well, if we were going to produce it all, we'd produce here, right? Q prime. Because that's where marginal cost equals price, right? And marginal cost is increasing. But at Q prime, we can see that our average variable cost is greater than our price. Right? In other words, what we can see is that the amount that we're paying to produce each unit is greater than the amount that each unit brings in revenue, which is going to tell us that our producer surplus is negative, and we're better off producing 0 than producing Q prime. This is exactly equivalent, right, to saying that this area here, where we're making money, is smaller in this case than this area here when we're losing money. But because we're aggregating up our costs, we don't have to calculate our integral of marginal costs. Cool. So long story short, right, we're going to be willing to produce at any price where our average variable cost, calculated at the quantity where marginal cost equals price, is going to be less than the price. In other words, any price above here, right, we're going to be willing to produce, right, because we would say that when calculated at our point where marginal cost equals price, average variable cost is going to be below our price. But any price below that, like this one, we're going to say that it's not worth it to produce. Because if we were going to produce, we'd produce at Q prime. But at Q prime, right, the average unit is bringing in less revenue than it's costing us. So one last thing I want to hit you with on this. If we know that it's worth it to produce, does that necessarily tell us that we're making a profit? And the answer to this is going to be no in the short run. Because when we have fixed costs, right, it might be that we're going to make a loss when producing an output like Q star, but not as horrendous of a loss as we would have made if we hadn't produced at all. In other words, right, we know that our total costs are going to equal C of Q, right? Our variable costs are going to equal C of Q minus C of 0. Right? So it might be worth it to us to produce because C of Q minus C of 0 is less than our revenue, but we might still make a loss if we have a large C0. So we'll call C0 here our fixed cost, right? Fixed because it doesn't depend on how much we produce. We pay it whether we produce nothing or whether we produce a lot. And we'll say that our profit is going to depend not just on the costs that determine our choice, right, C of Q minus C of 0, but also on our fixed cost. So in order to deal with this, right, the same way that we define average variable cost by dividing this thing by Q, we'll define average total cost by dividing our total costs by Q. Graphically, right, our average total costs have to be greater than our average variable costs, right, because they include C of 0. They have to get closer to our average variable costs as we increase production, because we're dividing C of 0 by a larger and larger number, right? This is, of course, going to equal our average variable costs plus C of 0 over Q. And so they'll look something like this. So if we had a picture like this, right, we would find that, well, it's worth it for us to produce, right, because our average because it's worth it for us to produce because our average variable costs are less than the price. We're not going to end up making a profit because our average total costs are going to be greater than the price. Right? In other words, we're doing better by producing than we would by not producing, but we're not doing well enough to pay for the capital that we already bought and that we're going to have regardless of our decision to produce. Our profit is going to be price minus average total cost times Q. And it's going to be greater than our consumer surplus, or equal if we don't have any fixed costs, because of the fact that fixed costs don't play a role in calculating consumer surplus, do play a role in calculating profit. So to sum all this up, right, we basically have three cost functions that play three different roles. We have our marginal cost, which is the derivative of our cost function with respect to Q. And this tells us how much to produce, if at all. Right? We'll find out how much to produce by setting marginal cost equal to price when marginal cost is increased. We have average variable cost, right, which is going to equal C of Q minus C of 0 over Q. This is going to tell us should we produce. Right? And we'll produce if price is greater than average variable cost, greater than or equal to average variable cost. We can also say, calculated at Q star. We can also say that our producer surplus is going to equal price minus average variable cost, Q star, times Q. Right? This is the benefit of the producer from being in the market. And then lastly, we have average total cost, just going to be the cost of Q divided by Q. And this is going to tell us how much profit we made. Right? And our rule is going to be our profit from Q is just going to equal price minus average total cost times Q. An important point here, these first two costs are what make our decision for us, right? How much will we produce if it's worth it to produce? Should we produce at all? This last cost, average total cost, is just our way of keeping score. It just tells us whether, once we decided to produce or not, we made a profit, and if so, how much we made, a profit or a loss. So to put a little meat on all this, let's go back to the cost function we started with, right? C of Q equals 5Q squared plus 80. And let's calculate our marginal cost, average total cost, average variable cost, and figure out whether it's worth it to produce. So in this case, right, as we said before, marginal cost is going to be 10Q, right, the derivative of CQ. Let's say, by the way, we've got a price equal now to 20, right? So we've got a marginal cost of 10Q. We can find our optimal choice of output by setting marginal cost equal to price, right? So we can say 10Q equals P. Q is going to equal 20 over 10 equals 2. Sorry, Q is going to equal 20 over 10 equals 2. Awesome. Then we ask, right, is it worth it to produce at all? If we produce at all, we'll produce 2 units of output. Okay, so to know if it's worth it to produce at all, and to find our producer surplus, we'll want to calculate average variable cost, which is going to be C of Q minus C of 0 divided by Q, right? So this is going to be 5Q squared minus plus 80 minus C of 0, which is just 80, divided by Q. So we'll say ABC of Q is just going to equal 5Q, right? 5Q squared over Q. So now, right, to calculate our producer surplus at our optimal output, we'll say ABC of 2 equals 5 times 2 is 10. So price is greater than ABC, right? Price is greater than 10, so it's worth it to produce. And our producer surplus is just going to equal, right, 20 minus 10, price minus average variable cost times 2 is going to equal 20. Right, so we'll make $20 more by producing than we would if we didn't produce. Last thing we want to know, did we make a profit? We can calculate our average total cost of Q is just going to be C of Q over P, right? So this is just going to be 5Q squared plus 80 over Q. Oh my gosh, sorry, C of Q over Q, right? So in this case, our average total cost of producing 2 units is just going to be 5 times 2 plus 80 over Q is just going to be 10 plus 80 over 2 is going to equal 50. So what was our profit? Our profit is going to be price minus average total cost times Q. So it's going to be 20 minus 50 times 2 is going to be negative 60. Right? So essentially what we're finding here is, given this problem, given this situation, we're going to want to produce 2 units of output. It's going to be better than to produce than to not produce, and we'll be $20 better off by producing than we'd be if we couldn't. However, because we had to pay for our capital, right, regardless of whether we produce, we'll end up running at a loss despite the fact that it was better for us to produce than to shut down entirely. Okay, great. So the last thing I'll leave you with today, which we'll talk about in the next video, is how our long-term costs are going to compare to our short-term costs and how that's going to affect our decisions.